In the first video on bit manipulation, you learned about the bitwise operators in C. To make use of these operators, let's explore a couple of problems. First, given a variable b, set the third bit to 1. No other bits should be changed. We count bits from right to left, starting at position 0. So the bit at position 3 in our variable b has the value 0. We can use the bitwise OR operator here. 0 or 1 is 1. 1 or 1 is also 1. Let's use the value 8. In binary representation, the value 8 has a 1 at the third bit. Using bitwise OR, any value we combine with 8 will end up having a 1 at the third bit. Now let's tackle another problem. Given a variable b, check if the second bit has the value 1. We will use the AND operator because the only way that bitwise AND results in 1 is if both bits are 1. We use the value 4 since it has a 1 at the position we want to check. If the second bit of b were 1, then 1 and 1 would be 1. But in our example, the second bit is 0, so 1 and 0 is 0. Suppose we want to make these problems more general. Our solutions so far rely on us knowing exactly which position we want to check. So now we need a way to create a value with an arbitrary bit set to 1. For that, we will use C's shift operator. There are actually two shift operators, shift left and shift right. Think of them as arrows pointing in the direction of the shift. The shift operators take two operands. The first operand, to the left of the operator, is the value to shift, and the second, to the right, tells us how many places to shift. If we shift the value 1 to the left 3 positions, we end up with 2, and then 4, and then 8. So by replacing the second operand with a variable, we can generate a value with any single bit set. This allows us to solve our general problems. To set the kth bit of var, we will bitwise OR var with 1 shifted k times. And similarly, we can check if the kth bit is set by bitwise ANDing var with 1 shifted k times. These two operations, setting and checking a single bit, are very common. It's worth learning these useful programming idioms. However, we can use the shift operators on values other than 1. In this example, we shift a 1-byte value, that is an 8-bit value, to the left by 1 position. The leftmost bit is discarded, and the rightmost bit is set to 0. The other bits are shifted 1 bit to the left. If we shift by 2, the leftmost 2 bits are discarded, the rightmost 2 bits are set to 0, and the other bits are shifted 2 to the right. Here's another way to think about the left shift operator. Look at what happens whenever we shift a number 1 bit to the left. I'm sure you can see the pattern. It's the same as multiplying the number by 2. We have focused on the left shift operator in this video because it was useful for our problem, but the right shift operator is also useful and works in the same way. In this example, you can see that the right shift operator works like integer division.